Section 1. Introduction to Vector Databases. Upbeat background music starts playing. Animated text vector databases for net AI apps appears on screen voiceover. Did you know that 80% of data is unstructured and traditional search methods can't effectively retrieve it? Think about it. Images, videos, audio files, and text documents are all unstructured data that can't be easily searched using traditional methods. Well, what if I told you there's a solution that can help you unlock the power of this unstructured data? Animated graphics of unstructured data types appear on screen voiceover. Welcome to the world of vector databases. As a net developer, you're likely building AI-powered applications that require efficient and accurate data retrieval. That's where vector databases come in. By using vector embeddings, you can enable your applications to search and retrieve unstructured data in a more intelligent and effective way. Animated graphics of vector embeddings and databases appear on screen voiceover. In this video, we'll explore how to use vector databases with Net AI apps. We'll be focusing on popular tools like Novus, Pinecone, and Mediate and showing you how to integrate them with your net applications. Whether you're building a recommendation engine, a chatbot, or how do we tackle the challenge of searching unstructured data? That's where vector databases come in. Unlike traditional databases that store data in tables with well-defined schemas, vector databases are designed to store and manage vector embeddings, a compact representation of complex data like images, text, or audio. Think of a vector database like a librarian that helps you find books with similar topics even if you don't know the exact title or author. It does this by converting your search query into a vector and then finding the closest matches in the database. Vector databases like Novus, Pinecone, and Mediate are optimized for similarity search and machine learning applications. They use algorithms like HNSW and IVF to efficiently index and query large datasets. For example, Novus is an open-source vector database that supports scalar and vector data types and is widely used in applications like image and video search, recommendation engines, and natural language processing. By using a vector database, you can unlock the full potential of your unstructured data and build more accurate and efficient AI models. In the next section, we'll dive deeper into the benefits of vector search and how it can improve your Met AI applications. Section 3. Benefits of vector search. You might be wondering, what's the big deal about vector search? Well, let me tell you. By using vector search in your AI applications, you can unlock a whole new level of accuracy and efficiency. Traditional search methods rely on keyword matching, which can lead to irrelevant results and poor user experiences. Vector search, on the other hand, allows you to search for similarities between vectors, enabling you to find the most relevant results. For example, imagine you're building a recommendation engine for an e-commerce platform. With vector search, you can create a vector representation of each product, taking into account features like price, brand, and description. When a user searches for a product, you can use vector search to find the most similar products, resulting in more accurate and personalized recommendations. Using vector search in AI applications like this can improve accuracy by up to 30% and reduce latency by up to 50%. It's no wonder that companies like Netflix, Amazon, and Google are already leveraging vector search in their applications. In the next section, we'll explore popular vector database options like Pinecone, Weaviate, and Novus, and see how you can use them to supercharge your net AI apps. Let's dive in. Now that we've covered the benefits of vector search, let's take a look at some popular vector database options that you can use to take your net AI apps to the next level. One of the most well-known vector databases is Pinecone, a cloud-based service that provides a managed vector database experience. It's highly scalable, supports filtering and metadata, and has a simple API for indexing and querying vectors. Another popular option is Weaviate, an open-source vector database that's built on top of GraphQL. It provides a flexible data model, supports various media types, and has a strong focus on data security. Novus is another widely used vector database that's designed for large-scale AI applications. It's highly performant, supports various indexing algorithms, and has a comprehensive set of APIs for data management. All of these vector databases have their strengths and weaknesses, and the choice ultimately depends on your specific use case and requirements. For example, if you're building a net app that requires low latency vector search, Novus might be a good fit. On the other hand, if you're looking for a managed service with a simple API, Pinecone could be the way to go. Let's take a closer look at Novus and see how you can use it with your Minutes Net AI applications. Novus is an open source vector database that supports scalar and vector data types, making it a great choice for AI-powered search and recommendation systems. To get started with Novus, you'll need to set up a local instance or use the cloud-based Novus service. Once you have Novus up and running, you can start indexing your vector data using the Novus Net SDK. The SDK provides a simple and intuitive API for creating collections, inserting data, and querying vectors. For example, you can create a collection with a vector field using the create collection method and then insert vector data using the insert method. To query the data, you can use the search method, which returns the most similar vectors based on the specified distance metric. One of the key benefits of using Novus is its support for various indexing algorithms such as IVF and HNSW, which enable fast and efficient querying of large vector datasets. Additionally, Novus provides a range of query operators, including scalar and vector queries, allowing you to filter and refine your search results. With its flexible data model and powerful query capabilities, Novus is an excellent choice for building scalable and accurate net AI applications. As we explored Novus as a powerful vector database option for net developers, let's now turn our attention to another exciting open source vector database, Qdrat. Qdrat is designed to provide a simple and efficient way to store, search, and manage vector data. One of its standout features is its support for filtering and payloads, which allows you to attach additional metadata to your vector data and filter search results based on specific conditions. For example, imagine you're building a recommendation system that uses vector search to suggest products based on user behavior. With Qdrat, you can store additional metadata such as product categories, prices, and ratings, and then filter search results to show only products that match specific criteria. This can be incredibly powerful in refining your search results and providing more accurate recommendations. Qdrat also provides a Foundation Net client library, making it easy to integrate with your future Net AI applications. Its lightweight and modular design allows for flexible deployment options, whether on-premises or in the cloud. As we continue to explore vector databases for Net AI apps, Qdrat is definitely worth considering for its ease of use, flexibility, and powerful features. Let's take a closer look at how Qdrat can be used in real-world scenarios.
Now that we've explored Qdrat's features, let's dive into the nitty-gritty of indexing and querying techniques. When working with vector databases, efficient indexing is crucial for fast query performance. Qdrat, like many other vector databases, supports various indexing techniques, such as HNSW, Hierarchical Navigable Small World, and IVF, Inverted File. HNSW is a popular choice for its balance between accuracy and performance. It builds a graph-based index that allows for efficient querying. IVF, on the other hand, is a more aggressive approach that sacrifices some accuracy for faster query times. The choice of indexing technique depends on your specific use case and requirements. For example, if you're building a recommendation system, you may prioritize accuracy over speed. In this case, HNSW might be a better fit. However, if you're building a real-time search application, IVF could be a better choice. When it comes to querying, Qdrat supports various query types, including exact and approximate nearest neighbor search. You can also use filtering and payload support to refine your queries. By combining these techniques, you can build powerful and efficient search functionality for your Net AI apps. Let's see how these techniques can be applied in a real-world scenario. Now that we've covered the basics of indexing and querying techniques, let's talk about integrating vector databases with popular Net AI frameworks. This is where things get really exciting. Imagine being able to leverage the power of vector search in your ML, Net or Accord Net applications. For example, with ML Net, you can use the ML Net vector package to work with vector embeddings and integrate them with Milvus or Qdrant. Simply create a vector index, add your embeddings, and query the index using the ML Net APIs. Similarly, with Accord Net, you can use the Accord Net vector package to work with vector data and integrate it with a vector database like Weavy8. Weavy8 provides a Net client library that makes it easy to interact with their vector database. By integrating vector databases with Net AI frameworks, you can build applications that can efficiently search and retrieve complex data. For instance, you could build a recommendation system that uses vector search to suggest products based on user behavior. Or, you could build a natural language processing application that uses vector search to retrieve relevant documents. The possibilities are endless, and we're just getting started. Let's explore some real-world examples of how these integrations can be used in practice. Now that we've explored the possibilities of integrating vector databases with Net AI frameworks, let's dive into some real-world examples of how these integrations can be used in practice. One example is a semantic search engine built using ML Net and Milvus. By indexing text documents as vectors, the engine can efficiently retrieve relevant results based on semantic meaning, rather than just keyword matching. This approach has been used in production environments to improve search accuracy and reduce latency. Another example is a recommendation system built using Accord Net and Qdrant. By indexing user behavior and item features as vectors, the system can identify patterns and make personalized recommendations. This approach has been used in e-commerce and content streaming applications to improve user engagement and conversion rates. These examples illustrate the power of vector databases in Net AI applications. By leveraging the strengths of both vector search and traditional databases, developers can build more accurate, efficient, and scalable AI solutions. Whether you're building a search engine, recommendation system, or chatbot, vector databases can help you unlock the full potential of your data. Let's take a closer look at how these integrations work in practice, and explore some code examples to get you started. Now that we've discussed the benefits of integrating vector databases with Net AI frameworks, let's dive into some real-world examples of how this works in practice. One popular use case is building recommendation systems. For instance, imagine you're building an e-commerce app using ML Net, and you want to recommend products based on user behavior. By indexing product embeddings in a vector database like Milvus, you can quickly retrieve similar products and display them to the user. Another example is image search. With Accord Net, you can extract features from images and store them as vectors in a database like Qdrant. Then, when a user uploads a new image, you can query the database to find similar images. These integrations are surprisingly straightforward. For example, with ML Net, you can use the ML context to create a vector index and store it in Milvus. Then, when you need to make a prediction, you can query the index and retrieve the most similar vectors. Similarly, with Accord Net, you can use the image feature extractor to extract features from images and store them in Qdrant. The possibilities are endless, and I'm excited to see what you'll build with these tools. As we've seen throughout this video, vector databases like Qdrant can be a game changer for Net AI applications. By leveraging the power of vector search, you can build more accurate and efficient models that can handle complex data types like images, text, and audio. The key takeaway is that vector databases provide a scalable and performant way to store and search high-dimensional data, which is essential for many AI and machine learning applications. By combining Qdrant with popular Net libraries like Accord Net, you can unlock a wide range of possibilities for building intelligent applications. Whether you're working on image recognition, natural language processing, or recommender systems, vector databases can help you take your projects to the next level. If you enjoyed this video and want to learn more about building AI applications with Net, consider subscribing to this channel for more content. I'd love to have you join the community. Don't forget to like, comment, and share this video with others who might be interested in vector databases and net AI. Your support helps me create more high-quality content like this. Thanks for watching, and I'll catch you in the next video. Quote.